Okay, so if you have your k value here, you have -2. Remember your upside down division bracket. And it's 3, 2, 1. So all of your exponents are in descending order, so we're good there. So you put your coefficients, 3, 8, 5, and -7. Okay. So remember that first one, you just bring it down. Okay. So -2 times 3 is -6. And you add those two together. 8 plus -6 is 2. So now you multiply. -2 times 2 is -4. And you add those together. Okay. So 5 plus -4 is 1. -2 times 1 is -2. And we add those together. -7 plus -2 is -9. Okay. So this is your remainder. Okay. So remember, this is your k, and this is your remainder, which we'll call r. Okay. So what this says is that if r equals f of k, then that means that f of k, or f of k equals r. Okay. That means that f of -2 is equal to -9. All right. Now, it doesn't tell you anything else except that if you go to this graph and pick -2, that value is -9. And we can always double check it just by plugging in -2. So f of -2 is 3 times -2 to the third plus 8 times -2 squared plus 5 times -2, minus 7. Okay, so that's going to equal 3. -2 to the third is -8 plus 8 times +4 plus 5 times -2, which is -10. We can go ahead and do that one now. Minus 7. So you have -24 plus 32 minus 10 minus 7, which actually gives you -9. So this is just a really fast way to do what we just did there. All right, so any questions on that one? All right. Okay, so you have actually 3 different results that you can have for the remainder theorem. Results of synthetic division. Okay. The first one is the one we just proved, that the remainder r obtained by synthetic division of f of x by k shows, actually put the one a little too early. That's the one. Okay. The remainder r gives the value of f at x equals k, which is how we got our r equals f of k. Oops, slide that over a little. Number 2, if your remainder is equal to 0, then we know that x minus k is a factor of f of x. Okay. That's kind of like if you divide 8 by 2 and you get a remainder of 0, then you know that 2 is a factor of 8. So it's kind of the same idea here. Okay. And again, if r is equal to 0, then the point k0 is an x-intercept. Okay, so those are kind of the 3 rules. We'll mainly only focus on rule number 2. The other 2 are kind of those good to know category. All right, so let's do a couple of examples. Okay, so for example, which function has a rational 0 of 10? Okay, so let's say for function a, you have g of x is equal to 2x to the third minus 11x squared plus 18x minus 80. Okay, let's say for function b, we have g of x is equal to x to the third minus 11x squared plus 18x minus 60. Okay, let's say for function c, we have g of x is equal to x to the third minus 11x squared plus 18x minus 80. And for d, we'll let g of x equals 2x to the third minus 11x squared plus 12x minus 60. Okay. So a rational 0 is just basically saying where f of x is equal to 0. So if you set all of that equal to 0 and you want to find the x values. Okay. To be honest, that'd be a whole lot of factoring and a lot of unnecessary work. But we can just use the remainder theorem with synthetic division and it'll solve each one within about 20 seconds. Okay. So use the remainder theorem. In this case, k is equal to 10. To test each one. All right, so for polynomial a, if k is equal to 10, remember we put our 10 on the outside in our upside down division bracket. And we just put our coefficients up. So you have 2, negative 11, 18, and negative 80. So 2, negative 11, 18, and negative 80. Okay. So remember your first step is you're going to bring down your first coefficient. So you're going to bring down the 2. 10 times 2 is 20. So you put 20 up here, add it together. Negative 11 plus 20 is 9. So bring the 9 down here. 10 times 9 is 90. So we add them together. 90 plus 18 is 108. 10 times 108 is 1080. Add those together, and we don't even have to add them together because we know it's not 0. Okay? So we know that this polynomial doesn't cross the x-axis at 10. It may cross it somewhere else, but we know it doesn't cross the x-axis at 10. Okay, so this one's not a 0, or not a rational 0. Okay, so now we do the same thing for B. Again, just plugging in the coefficients. Okay, so remember our k is equal to 10. Okay, so our coefficients is 1, -11, 18, and -60. 1, -11, 18, -60. Okay, so we get our first one and just bring it down. Okay, so you have 1 here. 10 times 1 is 10. Add them together. -11 plus 10 is -1. 10 times -1 is -10. We add them together. 18 plus -10 is +8. 10 times 8 is 80. We don't have to add them because we know it's not 0. Okay, so we know that 10 is not a rational 0 of B. All right, so now we do the same thing for C. Okay, we put our 10 here, our upside down division bracket, and we write all of our coefficients. So you have 1, -11, 18, and -80. Okay, so you get your first one and just bring it down. Okay, so 10 times 1 is 10. Add these together. -11 and 10 is -1. So now you multiply 10 times -1, which is -10. Add these two together. 18 and -10 is +8. 10 times 8 is 80. If you add these together, you get 0, which is the remainder you were looking for. Okay, so that means for this, for C, if you graph C, that graph will cross the x-axis at 10. So 10 is a rational 0 of C. Okay, so we found one. Now we just check the last one. Okay, remember, we put our k on the outside. And we get our coefficients, which are 2, -11, 12, and -60. Okay, move that up some. So you get your first one and just bring it down. 10 times 2 is 20. Add them together, you get 9. 10 times 9 is 90. Bring that up here. Add these together, you get 102. 10 times 102, 1020. We don't have to add it because we know it's not 0. Okay, so we know this is not a rational 0, or 10 is not a rational 0. Of D. Okay, so that's a whole lot easier than replacing g of x with 0 for all of those, trying to factor and do all the other stuff just to find out where it equals 0. All right. Okay, so any questions on that one? All right. So we know for this one our r is equal to 0. So whenever your r is equal to 0, that's when you know that's a 0 function. Well, 0 for the function. All right, anyone still writing? Nope. All right. Okay, so now we're going to do what they call a rational zero test. Okay, so you have the general definition, and then I'll give you the kind of the rundown. Okay, so if you have, let's say, if the polynomial let's say f of x is equal to some lead coefficient times your leading exponent. Let's say you have the next coefficient down and the next exponent down. And let's say it keeps on going all the way till you get to the coefficient of x and then your constant right at the end. Okay. If that polynomial has integer coefficients, all that means that every number in front of the x terms are just integers, either positive or negative. Then every rational zero of that function has the form okay, so let's say your rational zeros is equal to the factors of the term a0 or a sub 0 divided by a factor of the leading coefficient. Well, factors of the leading coefficient. That a is actually not accurate. A lot of times it's more than one. Okay, so that's where the numerator and denominators don't have any common factors. Uh-oh. Have no common factors. Okay, so let's say, for example, just to kind of give you an idea of how that applies. We wanted to find the possible, well, I guess it's not even possible, find the rational zeros. Actually, that's what's missing up here. This should be possible rational zeros. There we go. You know, I was missing a possible somewhere. Of, let's say, f of x equals x to the fourth minus x to the third plus x squared minus 3x minus 6. Okay. So for this one, your a sub n is going to equal 1. That's your lead coefficient. And your constant coefficient, a sub 0, is going to equal negative 6. So all your possible, bless you, rational zeros, which would be your factors of a 0, divided by the factors of your lead coefficient. And if you're ever confused as to which one goes where, always say 0 and n on. So that's kind of my little shortcut on. So again, horrible memory, you kind of think of little things like that. Okay, so the factors of -6 is positive or negative 1, positive or negative 2, and positive or negative 3. All of those go into 6. Okay, so your possible factors of 1 is really just positive or negative 1. Okay, so whenever you have positive or negative 1 in the denominator, you can kind of get rid of it. All right, so that means your possible factors or possible zeros is positive or negative 1, positive or negative 2, and positive or negative 3. Oh, and positive or negative 6. Forgot about that one. Okay, so those are all factors of 6. Okay, so what you have to do here is actually plug in each one by one and use synthetic division and hope you get a remainder of 0. Okay, so let's say if we try -1. And actually, I think I'm going to start this on the next page because we're running out. Oh, anyone's still writing this one? All right, I'll leave that up for a few. Okay, I'll just... All right. Okay, so just so we won't have to keep switching over, we know f of x is x to the 4th minus x to the 3rd plus x squared minus 3x minus 6. And our possible rational zeros, positive or negative 1, positive or negative 2, positive or negative 3, positive or negative 6. Oh, just so we don't have to keep switching over from page to page. Okay, so now we start with -1, or your k equals -1. Okay, so you have your -1. Now you just put in your coefficients. So you have 1, -1, 1, -3, and -6. Okay, so we just bring down our 1. -1 times 1 is -1. Add them together. You get -2. Oh, clean that up a little. Okay, -1 times -2 is +2. Add those together. You get 3. -1 times 3 is -3. Add those together. You get -6. -1 times -6 is 6. Add those together. You get 0. Okay. All right. So r is equal to 0. So we know -1 is an actual 0. Is a 0 of f of x. All right. Now remember before, when we had, this is our x to the 4th, this is our x to the 3rd, This is our x squared. This is our x, and this is just our constant number. Remember, down here it goes down 1. So this x to the 4th, this becomes x to the 3rd. This x to the 3rd becomes x squared. Let me clean that up a little bit. This x squared becomes x. And this x just becomes a constant. Okay? Now we know -1 is a 0. Okay? So that means we're looking for f of x equals x minus something times x minus something times x minus something times x minus something. Okay? We know we have 4 because it's to the 4th power. Okay? But since we know -1 is a 0, we can plug one of those in. Okay? So that means, at least for now, we know it's f of x is equal to 1x to the 3rd. Well, I guess you can put that down there. Well, I guess you can just put x to the 3rd instead of 1x to the 3rd. So x to the 3rd minus 2x squared plus 3x minus 6 times, this is a 0, so it's going to be x minus -1. Which becomes x plus 1, but we can do that step later. Okay, so all we did was get this original one, and we brought out one factor, which was the -1. Okay, but we still have to factor this. Okay, so we can actually use synthetic division again. But now we don't have to use -1 since we already used it. So now we can use +1, -2, +2, and we have to kind of go through the entire process. Okay, so we already have -1 out the way. Okay, so now we just have to factor that. Okay, so find the 0 for x cubed minus 2x squared plus 3x minus 6. So we don't have to use the one we started with anymore. Oh. Okay, because we've already found a 0 of that one. Now we're just looking for this one. Okay, so we still have +1. So x equals 1. Okay, not x equals 1, k equals 1. Sorry about that. Okay, so k equals 1. Now we use these coefficients. So you have 1, -2, 3, and -6. Okay, so just like before, we get our first one, bring it down. 1 times 1 is 1. Add them together. -2 plus 1 is -1. Multiply them. 1 times -1 is -1. Add them together. 3 plus -1 is 2. 1 times 2 is 3. So we know it's not 0, so it doesn't matter. Okay, so we're not going to use 1. Okay, so now we go to -2 and 2. Plug those in. So we'll start with 2. And since we didn't come up with a 0, we have to use these same coefficients. So we use the same coefficients until we get a 0. Okay, so now we go 2, 1, -2, 3, and -6. And 2 doesn't work, we use -2, then 3 and -3. Okay, so we bring our first one down, which is 1. 2 times 1 is 2. Add them together. -2 and 2 is 0. 2 times 0 is 0. Add them together. 3 plus 0 is 3. 2 times